Right, let's look at a MadAsMaths question. Perhaps surprisingly, I've actually gone for one that's not, insanely difficult. This is, it's one of the easier MadAsMaths questions I've chosen in a while, but I chose it because I think it just demonstrates a nice sort of principle when it comes to, information you're given and what you know and what you don't know. So I'm going to try and give you. I'm not going to really run through the question and give you much information other than just highlighting one thing before you read this. It says here at the bottom, determine the possible values, plural, of f, and in each case, the corresponding value of the tension in the string. Okay, so you're looking for multiple values, not just one. So have a look at the question, see if you can figure out where these multiple values might come from, and then if you struggle with a bit you can take a look at the working. Okay, but please do try it yourself first. It is an easier question once you can sort of figure out what it is that produces these multiple values. Okay, so pause the video now. Okay, so we're going to determine the possible values of f, and in each case the corresponding value of the tension in the string. Let me just go back to the question for a moment first though, just to read through it a bit myself. So you've got these two blocks, 4 kgs, 6 kgs, smooth, there's no friction, light and extensible string, keeps things simple. And there's two forces, F is moving left, and you've got this other force 30 moving right. And then it says the whole thing, the system, the whole thing moves and has a constant acceleration of magnitude 2. So what is the acceleration? Let me just go over here now then. So what is the acceleration? You've been told the magnitude of acceleration is 2. So that implies the acceleration is either 2 or it's minus 2. So there are two possibilities. What that corresponds to then is either the whole system is moving to the right because the force F is too weak, or the whole system is moving left because the force F is quite strong and is overcoming the 30 newtons pulling to the right. Okay, and what's interesting is that even though there's this symmetry in accelerations, A2 and A minus 2, you're not necessarily going to get a quote-unquote symmetry with the forces and the tensions. Okay, probably because you're working with different masses here. So in order to then see what the actual values are, we're going to have to go through the calculation. Right, so these are our two accelerations, and then let's see if we consider a bit of F equals ma, how we can get some forces and the tension. So, first off, let me just quickly draw it again myself. I find that even if you've been given a drawing, unless it's insanely complicated, it's a good idea to just briefly draw it yourself with the extra details, because then you start to get into the habit of really noticing the things in the image, even if this is a simpler case. Right, so we've got a string, and then what my force is. So I've got tension this way, I've got tension that way. Technically A and B have a weight, but I'm going to not bother including that on the diagram because we're only really interested in horizontal motion. Okay, so let's choose a direction for positive. I'm going to say right is positive. And let's see about our two cases. Okay. So, well, before we consider the two cases, actually, let's do F equals ma for both the points A and B, or both the boxes A and B. So for A, F equals ma would be the total force, the net force is T to the right minus capital F to the left, is equal to its mass 4 times the acceleration, whatever that may be. And for B, we've got 30 to the right minus tension to the left is equal to its mass times acceleration. again, whatever that acceleration may be. And now we can almost create a kind of, I suppose a table of possibilities here. In fact, let's do that. And within that, I'm going to include the working for the two possible scenarios. So let's pick a equals 2 first and a equals -2 as our second possibility. So when a equals 2, what do these equations become? We have t minus f equals 8, and we have 30 minus t equals 12. And then it's a little bit of simultaneous equations. For example, if I add the equations together, I get 30 minus f equals 20, and therefore f equals 10. And if f equals 10, that must mean that t is, so t minus 10 equals 8. I'm looking at the top equation here, must be 18. Okay, and let's just write that nice and clearly at the bottom here. So f equals 10, t equals 18. And in the other scenario, we've got almost the same equations except different acceleration. T minus f equals -8, and 30 minus t equals -12. So let's add them together again. We'll get 30 minus f equals -20. Is it -20? Have I jumped the gun there? No, that should be fine. F equals 50. And if f equals 50, then what must t be equal to? So t minus 50 gives me -8. Therefore, t must be 42. Okay, I've got here's my final answer then. F equals 50 and t equals 42. And these are the possible answers. Okay, these are the two possible values for f and the two possible values for t. Okay, and I think it's quite helpful to just consider for a moment, if I maybe go back to the original drawing because it's clearer, what do these values actually mean. So it's really good to have a sort of intuitive idea of what's going on. So let me just highlight these as, that's one possibility, and that's, another. So case 1 and case 2. So in case 1, it's saying F is quite a weak force. It's only 10, and this big force 30 is moving to the right, and therefore this 30 are working on this massive box 6, or well, not massive but bigger than the 4, is then causing the string to have a fairly small tension, 18, and that's then causing the whole thing to move to the right with acceleration 2. And alternatively, you've got 50 required moving to the left, and in that case that 50 is massive force needed to overcome this 30 that's pulling in the other direction, and that then overall as a net result will cause the whole thing to shift to the left, but that string is going to be suffering a lot more. So think of the tension almost as how much pain is this string feeling, like is this string being stretched quite hard or quite lightly. So in the second case, the string is having to do a lot of work, or work is not the right word, but the string is being acted on force-wise by quite a large force. It's got a tension of 42, more than double of case 1. The result is the same. There's an acceleration to the right or the left of 2 meters per second squared. The difference being, poor string has to suffer a bit more in case 2, because overall there's so much more force going on in case 2, so the string needs to compensate for this. Cool. Okay, but that is our final answer there for the question. That's case 1 and that's case 2.